So when you hear the name Dmitri Mendeleev, one image probably springs to mind.
The periodic table. It's on the
Yeah.
wall of every chemistry classroom in the world.
Exactly. And it is, without question, the cornerstone of modern chemistry. But to frame him only as the man who organized the elements is to miss the entire wildly complex person.
Right. The sources you've given us challenge that image completely. They reveal this true polymath. A chemist, yes, but also a physicist, a dedicated economist, a groundbreaking industrial consultant.
An agricultural innovator, the father of modern Russian metrology.
And my favorite, a solo expert aeronaut who, and this is a quote, almost thought he saw his own soul leave his body mid-flight.
That's absolutely right. The material we're working with today, memoirs, biographical excerpts, and even Mendeleev's own writings, it all spans his entire life. From 1834 to 1907, it paints a picture of this restless, deeply passionate genius.
So our mission today isn't just to list his discoveries.
No, not at all. We want to plunge into the context that forged him. We want you to understand how the harsh lessons of Siberian resilience, the constant backdrop of political turmoil, fierce academic rivalry, and just this boundless practical curiosity shaped a career that touched everything.
Everything from the deepest structure of matter to the formula for smokeless gunpowder, and yes, even the science of proper cheese production.
And trade tariffs. Don't forget the trade tariffs.
So this is a deep dive about connection. It's about seeing that great scientific achievements, they're never born in a vacuum. They're inseparable from an individual's character, their resilience, their politics, their emotions.
And their active, often confrontational engagement with the world's messy, practical problems. For you, the learner, this is a shortcut to understanding the man behind the elements and why his life was just this constant battle against intellectual inertia and bureaucracy.
Indeed. We should probably start at the very beginning of this monumental life.
Let's do it.
Okay, let's unpack this phenomenal story. Section 1. The Siberian Crucible Family, Survival and Intellectual Beginnings. Dmitri Ivanovich Mendeleev was born in Tobolsk, Siberia in 1834. And right from the jump, the memoirs reveal a life marked by survival and struggle, and it all seems to center on his mother.
His mother, Maria Dmitrievna, she is, and you can't overstate this, arguably the most important figure in his entire history. When Dmitri was born, his father, Ivan Pavlovich, lost his sight.
From cataracts, right.
Yes, though he did partially regain it later. But in that moment, overnight, Maria became the sole breadwinner for their enormous family. Dmitri was the youngest of as many as 17 siblings.
17? Wow.
Well, only 14 survived infancy, which tells you something about the time. And the family survived because of her sheer determination. The sources describe it as an iron will.
She took over the family glass factory in Aremziansko.
She did more than take it over. She revived it. It was basically a dead enterprise, and she transformed it into a viable business.
And she ran it in a way that was pretty unusual for the time.
Oh, incredibly progressive. The biographical notes tell us she paid her staff city wages. Now, you have to understand, this was almost revolutionary in rural Siberia, especially when serfdom was still a recent memory. It just speaks to her profound sense of fairness.
And she was doing all this while also running the farm.
Exactly. Raising livestock, growing grain, managing a massive garden.
And crucially, she involved young Dmitri in all of it.
Yes, the sources are very specific about this. She taught him the art of glassblowing, so he was learning hands-on about melting, shaping, cooling materials, linking the theory of heat and matter with actual manual work.
But her real focus was his mind.
Always. She saw something special in Matenka, her favorite son, and she committed everything to his education. She moved the entire family to the city of Tobolsk solely so he could attend gymnasium. She had this dream of higher education for him.
That determination is just incredible, especially when you consider the social backdrop. I mean, Siberia at that time was rough.
It was a place of extremes. The sources paint this vivid picture of the Million-shuki, these wealthy merchants. Their main entertainment was, and I'm quoting, continuous drunkenness and cards.
They just gamble away fortunes.
Truly monumental sums. Sometimes the annual income of an entire family just on a card game. It was vast wealth, sudden poverty, and very little in between.
And some of the customs from that time are, well, they're bizarre. The story of the circa, the chewing resin, is just completely strange.
It's the perfect microcosm of this untamed energy, isn't it? So the circa was tree resin. When guests arrived, they'd find a piece of it stuck under the tabletop from the last person.
And they would just chew it.
They'd pop it in their mouth and chew this recycled resin until the huge Siberian feast was finally served. Then they'd stick it back under the table for the next guest.
That is something else.
But here's the critical balance. Despite all that chaos, Siberia was also this unique pocket of intellectual activity, and that was primarily because of the Decembrist exile.
These were the educated nobles and military officers who had been exiled after the uprising against Tsar Nicholas I in 1825.
Exactly. And this is where Mendeleev absorbed this crucial idea that intellectual pursuits and radical social application could be fused together.
Do the memoirs give any specific examples?
Oh, several. There was a man named Wilhelm Sigismund von Tessenhausen. He was a Catholic colonel exiled to Yelutrovsk. The locals thought he was a sorcerer because he had these statues of nymphs in his basement.
Right, in a deeply superstitious community.
But he ignored all that and just became the town's first agronomist. He was out there manually planting apple trees, applying systematic knowledge to improve local life. He was an intellectual who got his hands dirty.
And that idea must have stuck with Mendeleev.
It did. And there were others, Andrei Antaltsev, who became a doctor and treated everyone for free. Ivan Yakushkin, a major Decembrist figure who started the first parish school. These were people who saw science and education not as abstract things, but as tools for immediate community reform.
So he's absorbing all this, but his own formal education was a bit rocky at first.
It was. He struggled terribly with classical languages. He hated Latin.
He even ended up on the blackboard for fighting with his Latin teacher.
He did. His mind just wasn't built for rote memorization of languages, but he excelled in mathematics and physics. He had an immediate affinity for quantifiable natural laws.
So by 1849, he finishes gymnasium, and his mother prepares the family for this epic journey west.
Epic and dangerous. The main threat was a massive cholera epidemic raging along the Moscow tract. They had to deal with armed cholera outposts at every town, which drove up the price of travel.
And his mother's solution was very pragmatic.
It was a mix of faith and folk remedies. She put her trust in Hoffman's drops, vinegar, and a whole bag of garlic to keep them safe.
That image of her carrying the future of science and a bag of garlic across thousands of miles of cholera-ridden Russia. It's just so powerful.
It's the ultimate act of dedication. And then, tragically, after all that, they finally reach Moscow, only to be struck down by bureaucracy.
Right. Which brings us to Section 2, the ill student and formative mentors. After surviving Siberia and that journey, he's denied entry to Moscow University in 1849. Why?
It was a decree from Tsar Nicholas I. It basically stipulated that students could only enroll in their local district. The Mendeleevs were from Tobolsk, Siberia, so no Moscow University for them. The bureaucratic wall was just immovable.
What a crushing blow. But his time in Moscow wasn't a total loss, was it? Thanks to his uncle.
His uncle, Vasily Kornilov. His salon was a critical intellectual hub, and it was there that young Dmitri met the literary elite. Figures like Nikolai Gogol, the great writer.
And Gogol made a huge impression on him.
A profound one. Decades later, Mendeleev still remembered seeing Gogol just sitting quietly, observing everything. He called him an unusual phenomenon and a worldwide magnitude who, and this is the key part, didn't understand himself.
That's a very insightful thing for a young scientist to notice.
It really is. It shows this deep sensitivity and intuition that went far beyond just numbers and formulas.
So, unable to stay in Moscow, they pushed on to St. Petersburg. And that's where the next great challenge was waiting, the complete collapse of his health.
St. Petersburg was merciless. He began suffering severe chest pains, throat hemorrhaging. He was soon diagnosed with advanced consumption tuberculosis.
And the prognosis was essentially a death sentence.
It was. This is a legendary moment in his biography. The institute doctor, Krabel, whispered to the director, right by Dmitri's bedside, that Mendeleev and another student will not rise.
He overheard his own death sentence.
He did, and he didn't despair. The sources say he immediately sat up, grabbed his notebooks, and just immersed himself in his studies. People who knew him then described him as a frail and too-veined man who shouldn't have survived the year.
Yet he lived to a respectable old age.
Through sheer, unyielding intellectual focus, the scarcity of life drove his productivity. And as he was recovering, his mind was being shaped by three intellectual pillars, three key mentors.
Who were they?
First was Mikhail Ostrogradsky in math and physics. Ostrogradsky taught a broad view, connecting physics, astronomy, mechanics. He refused to be stuck in one discipline, and that was vital for Mendeleev's later work.
Thinking across disciplines, not just within them.
Precisely. The second was Alexander Voskresensky, the father of Russian chemistry. Foster-Zensky instilled in him a knightly devotion to strict objectivity. Follow the facts, follow the data, and always be skeptical of theory without evidence.
And the third influence pointed him toward the basic architecture of matter itself.
That was his training in mineralogy. His very first published work was analyzing mineral samples. And that led him to his deep early work on isomorphism.
Well, let's pause there. Why was isomorphism, this idea about crystal geometry, so important for him?
Because isomorphism is the idea that different substances can form crystals with similar shapes. He was asking why. What are the hidden underlying physical laws that govern this geometry? He was searching for fundamental, repeatable patterns in the visible world.
So that quest for hidden laws in crystals was a direct precursor to searching for a hidden law for all the elements.
Exactly. He was asking, what is the deep structure that governs the visible structure? And it's fascinating because, despite becoming the world's most famous chemist, he always thought of himself as a physicist first.
He said a chemist cannot exist without physics.
Right. The goal was always unification. The sources also show he was incredibly sensitive. He held onto slights forever. And that sensitivity, combined with nearly dying, created this intense, frantic drive.
So that focus carries him into his crucial European journey. Let's move to Section 3. The European journey and the nature of matter. After the Crimean War, he sent abroad to Heidelberg and Paris. What made Heidelberg the place to be?
Heidelberg University at that time was the absolute epicenter for physical and chemical sciences. Germany's Industrial Revolution was booming, and the science was cutting edge. The faculty was a who's who of giants. Hermann Helmholtz was there, Robert Bunsen, Gustav Kirchhoff.
Bunsen of the Bunsen burner.
The very same. He was a heroic figure. He'd lost an eye in an arsenic experiment. It was an environment that showed science was high stakes, it was dangerous, it was revolutionary. While Mendeleev was there, Bunsen and Kirchhoff actually discovered two new elements, cesium and rubidium, with their new spectrograph.
But Mendeleev didn't just go there to sit at their feet. He remained independent.
Very much so. He actually felt that most of what was being taught offered little new, so he set up his own private laboratory, he bought his own equipment, and just obsessively tried to penetrate the visible boundary of matter.
And this independence led directly to a huge discovery, the critical temperature. How did he arrive at that?
Through pure, meticulous observation. In 1860, he was heating liquids water, ether in sealed glass tubes. He was watching them turn to gas under pressure. And he noticed the meniscus, that little curved surface of the liquid, started to flatten as it got hotter.
Wow.
And then, suddenly and completely, the liquid just vanished. The meniscus disappeared. He had found what he called the absolute boiling temperature, what we now call the critical temperature.
It's the point where liquid and gas become indistinguishable.
Exactly, where cohesion reaches zero. And this was so significant because other people had seen this happen, but they just dismissed it. Mendeleev realized this was a fundamental limit of the liquid state. It proved that liquid and gas weren't eternally separate things. They were on a continuum, governed by physical laws.
This idea of continuity and transformability,
Yeah.
that feels like the philosophical bedrock for the periodic law.
It absolutely was. He was defining the very boundaries of what matter is. But while his scientific world was exploding, the social world of the Russian scientists in Heidelberg was changing dramatically.
At first, it was a real intellectual hub, right?
Right.
With people like Borodin, the composer and chemist.
Yes, his initial circle was all about intense scientific discussion. But then, after St. Petersburg University was temporarily closed, a new wave of students arrived.
They were more politically motivated.
Completely. The reading rooms filled up not with chemistry texts, but with forbidden socialist literature. Scientific study was suddenly overshadowed by political disputes. So Mendeleev was always operating at this intersection of pure physical law and messy political reality.
And his dedication to finding order in chemical chaos must have felt like a sanctuary, which sets up Section 4 perfectly, the path to the periodic law.
He returns to St. Petersburg, takes up his professorship, and immediately confronts this crippling problem in chemistry. Total and complete intellectual anarchy.
It's hard for us to grasp today, but the sources describe a field that was just paralyzed by a lack of standardization.
It was. Atomic weights weren't agreed upon. Chemical symbols were a mess. If you were studying acetic acid, for example, you might find up to 19 different notations for it, depending on whose theory you followed.
19 ways to write one simple substance. Why was it so chaotic?
It came down to a fundamental confusion between atoms and molecules. And without a standard reference point for atomic weights, everyone's calculations were different. If you can't agree on the weight of your basic building block, you can't build any reliable theory.
So chemistry needed a universal language.
And Mendeleev found the key. He adopted the ideas of Dolf Gerhardt, who argued that gas particles like hydrogen actually existed as molecules of two atom arrows. Once you accept that, you can finally calculate relative atomic weights consistently.
So Gerhardt provides the standard, and Mendeleev provides the system to hold it all together.
Exactly. With consistent atomic weights finally available, he could pursue his goal to find the root properties of the elements based on two things: their ability to form compounds and, critically, their atomic weight.
He believed mass was the anchor for everything.
For both physical and chemical reality, he argued that chemical forces must depend on the mass of the atoms, just like gravity depends on mass. So if you arrange the elements by increasing atomic weight, their properties had to repeat periodically. For him, it was a physical necessity.
And that necessity leads to March 6, 1869.
Indeed. His paper, An Attempt at a System of Elements, was presented to the Russian Physico-Chemical Society.
But he didn't present it as a finished masterpiece.
No, he saw it as an experiment, an idea that was not yet finalized. The famous story about him playing with cards with elements written on them, that was him wrestling with the data. It took 2 more years to refine the table, correct the weights of some elements, and most famously, leave gaps for elements that hadn't been discovered yet.
And predict their properties.
And predict their properties with stunning accuracy.
But the reaction from some very influential colleagues was, well, it was hostile.
It was a classic case of academic turf wars. While his work was celebrated in England and France, many top German chemists, Bunsen, Kopp, were antagonistic. They had their own systems, their own ideas.
And this came to a head in 1880, right there in St. Petersburg.
It was a devastating academic slate. The Russian Academy of Sciences asked the Germans for recommendations. They recommended a narrow researcher named Friedrich Beilstein over the expansive, systemizing Mendeleev. The St. Petersburg Academy itself distrusted him. They preferred a pedantic technician over a polymath.
So they rejected him for the adjunct position.
They did. 9 votes for, 10 against. It was seen, rightly, as a suppression of Russian scientific talent.
And the public outcry was huge.
It was a massive national scandal. Professors across Russia and Europe elected him as an honorary member in protest. Mendeleev himself said, "I understand that the issue is about the Russian name, not about me." He saw it as a creative Russian spirit being stifled by bureaucracy.
And that rejection seems to have pushed him even further into the practical world. Section 5. The industrial and economic visionary. If the Academy didn't want his theories, he'd apply them directly to the nation.
Absolutely. He immediately focused his energy outward. After the 1867 World Exhibition in Paris, he wrote a huge report on how Russia must develop its industry, and that led him straight to the Baku oil fields.
And when he got there, he was horrified.
Horrified by the inefficiency and greed. The whole sector was choked by an outdated system of short-term leases. Operators had no incentive to invest in technology or drill efficiently. The sources say 150 Baku wells produced the same amount of oil as 24,000 American wells.
An appalling waste. And he had a very strong philosophical objection to how they were using the oil.
He saw burning crude oil as fuel as just a colossal waste. He famously said it was like burning banknotes.
He wanted them to refine
The
that.
full complex refinement, not just for kerosene, but for all the valuable chemical byproducts. He saw oil as a precious chemical feedstock for Russia's future, not just something to burn for heat.
And he championed the infrastructure to support that vision: pipelines, oil-carrying ships.
He did. But maybe his most compelling argument blended economics, chemistry, and sociology. It was his opposition to a tax on crude oil in 1886.
The Minister of Finance proposed it. Why did Mendeleev fight it?
He argued it would be a heavy burden on the working class. His reasoning was brilliant. He said cheap oil for lighting allowed laborers to extend their working hours during Russia's long, dark nights. Taxing crude oil would raise the price of light, effectively shorten their workday, and reduce their earnings.
He really saw himself as a political economist.
He did. He joked about it, but he was serious. He claimed his work on tariffs, a reasonable tariff, was more important than his famous chemistry textbook.
That ability to think across disciplines, it really peaked with the incredible story of his smokeless gunpowder, pyrocolodion.
The Russian military was in a panic in 1890. The French had developed a secret smokeless powder and were guarding the formula. Mendeleev was tasked with creating a Russian version.
And the French weren't talking. So how did he figure it out?
This is the genius of the polymath. He didn't steal the chemistry. He deduced it from logistics. He got his hands on the railway freight tables showing all the raw materials being shipped to the French powder factory.
So he just looked at the inputs.
Exactly. He tracked the tonnage of every material, excluded the irrelevant stuff like grain or coal, and focused only on the chemical inputs. By tracking the ratios of things like cotton and nitric acid going in, he could reverse engineer the recipe.
That is just brilliant.
Yeah.
And his final product was a success.
A technical triumph. He created a uniform nitrocellulose he called pyrocolloidine. It was highly stable, superior in some ways to the French powder.
But of course, the military establishment rejected it.
Another soul-crushing rejection. They ceased production by 1895. The reason? Pure professional jealousy. He was a civilian man who lacked the stamp of the higher artillery school. They couldn't accept that an academic could lecture them on ballistics, even if his product was better.
And a tragic pattern. But that same commitment to national standards led him to his next major government role.
In 1892, he took over as head of the Depot of Exemplary Measures and Weights.
Why was standardizing weights and measures so important for Russia then?
Because Russia was economically hobbled. They were still using traditional, inconsistent measures like the arshin and the funt, while the rest of industrialized Europe was on the metric system. Mendeleev knew that for industry and trade to progress, you needed standardization.
And he built a facility that reflected his obsession with precision.
Oh, the building was a marvel. The sources highlight these incredible anti-vibration foundations he insisted on. To keep the instruments perfectly stable, the support pillars were separated from the ground by air chambers. The labs were temperature constant. For him, precision in science began with precision in the environment itself.
A perfect parallel. The man who systematized the atom insisted on a perfectly stable lab floor. Let's shift now to Section 6, Aerostatics, Spiritualism, and Political Nonconformity. This is where we see his refusal to be bound by any convention.
His work on gases continued long after Heidelberg. He was studying their elasticity with practical uses for artillery in mind. And in his signature move, he ended up challenging established law.
The Boyle-Marriott law.
Right. His experiments proved it was inaccurate, especially at very low pressures. He was always testing the boundaries. And this research prepared him for his most public and probably most dangerous experiment, the 1887 solo eclipse flight.
He volunteered to go up alone in a hydrogen balloon, the Ruski. Why?
The balloon's lift capacity was too low for two people, plus the scientific gear. His stated motivation was to disprove the prejudice that we professors need a peasant to do the work. He wanted to prove that scientists must master the practical application of their theories.
He also had a very real fear about landing.
Yes, he was genuinely worried that superstitious peasants might see him descending from the sky during an eclipse and mistake him for the devil.
The flight was a success, but there was a strange mystery in his data.
Mendeleev, the champion of measurement, found that 10 minutes were just missing from his records. He couldn't account for them.
What did he conclude?
He figured he must have had a momentary loss of consciousness, a prostration from the altitude, but then he speculated, almost poetically, that perhaps his soul had gone somewhere else for those 10 minutes. Even for him, there was a boundary where objective science gave way to mystery.
And from the physical boundaries of the atmosphere, he dived into the metaphysical, taking on the spiritualism craze.
He saw it as old superstition dressing up as science, and he was determined to expose it. He formed a commission in 1876 to investigate mediums.
And the mediums weren't exactly thrilled with scientific scrutiny.
No. During sessions with a famous medium, Madame Claire, her supporters tried to restrict observation. So Mendeleev's team brought in a special table rigged with a manometer to detect any physical pressure.
And when she had to use the scientific table,
Nothing happened, no lifting, no movement. He concluded it was all trickery. He felt his investigation had stopped the painful interest in spiritualism, though it probably just drove it underground.
and this nonconformity extended to politics. He was a consistently unruly citizen.
A very outspoken advocate for intellectual freedom, which put him at odds with powerful government figures. He openly attacked the classical education reforms, this focus on dead languages like Latin and Greek at the expense of science.
He argued it would create a scientifically ignorant populace.
He did. He also fought against censorship. He wrote a piece for the newspaper Golos, which they were too afraid to publish in full, asserting that beliefs, concepts, books, and words should be free as air.
That kind of open dissent made him a target.
He was under secret observation, And eventually, disgusted by the constant student unrest and bureaucratic pushback, he submitted his resignation from St. Petersburg University in 1890. Over 50 professors begged him to stay, but his mind was made up. He refused to compromise his principles for a salary.
Which brings us to Section 7, Personal Life, Philosophy, and Final Years. Here we see the last dimensions of this complex man, including his defining philosophy of work.
His personal life was complicated. His first marriage was strained. He had to handle nearly all the practical domestic matters himself.
But that ended after a profound emotional crisis in the late 1870s.
Yes, he fell into a great passion for Anna Ivanovna Popova, a much younger art student. She recalled a moment during a chess game where the 43-year-old professor covered his eyes and wept, saying, "I am so lonely, so lonely." It was this raw vulnerability.
He married Anna in 1881, and they had several children.
And she brought stability, but also observed his intensity. This intensity was woven into his core philosophy, his distinction between two kinds of human effort.
This is the difference between Trud and Robota. It's essential to understanding him.
It is. Mendeleev saw Robota as the unwilling, tedious toil, the curse of life under capitalism. But Trud was the creative, free, inspired application of service to the people. His whole life was driven by the joy of creative Trud.
And you see this in his scientific battles. The Academy preferred the pedantic Robota of his rivals over his creative, unifying Trud.
Exactly. For him, Trud led to progress, while Robota just maintained the status quo.
And in his final years, he focused that creative Trud on one last massive project.
His final legacy. To the knowledge of Russia, a deep statistical analysis of the 1897 census. He loved data, and he used it to analyze the Russian character.
And his big controversial conclusion was
That we, Russians, labor very little. Wasn't saying Russians were lazy, but that their Robota was incredibly inefficient, especially in agriculture. He argued that the lack of industrialization meant human effort was being wasted.
And he was, fittingly, working until his very last breath.
Absolutely. His final written words, found in the supplement to that book, were an unfinished sentence. In conclusion, I consider it necessary, if only in general terms, to state. He died at his desk, pen in hand, in 1907.
And finally, we have to talk about the Nobel Prize controversy. Nominated multiple times, but he never won.
3 times, 1905, 1906, and 1907. And ironically, he was never once nominated by his own Russian colleagues. The academic opposition at home never really went away.
The initial roadblock was a technicality, a rule about the prize being for work in the preceding year.
Yes, but once they got past that, the opposition became personal. In 1906, the chemistry committee voted for him, 4-1, but the Swedish Royal Academy overruled them and gave the prize to Henri Moissan,
And a major force behind that was Svante Arrhenius.
the Swedish academic. Mendeleev had fiercely and publicly rejected Arrhenius' theory of electrolytic dissociation for years. Arrhenius was a powerful member of the Academy, and he made sure Mendeleev would not get the honor. It was the final devastating academic slight.
What an incredible life. A man who fought off death, defined the universe's building blocks, risked his life in a balloon, and fought bureaucrats every step of the way.
And his legacy is so much richer than just the table. His very resistance to new ideas like radioactivity actually ended up validating his framework in a new way. When physicists figured out the atomic number, it confirmed the fundamental structure of the periodic law. His resistance just pushed science to prove him right on an even deeper level.
His whole life was this battle, this tension between bureaucratic inertia, the Robota, and his own disruptive creative Trud.
Absolutely. So we leave you with this final provocative thought, pulled directly from his own philosophy. It feels particularly relevant in our world today. Mendeleev believed that for scientific work to truly succeed, you need free, creative work, Trud, not uninspired, tedious labor, Robota. So in our modern world of endless data, emails, and demands for constant, measurable productivity, how do you tell the difference between necessary labor and truly creative, pioneering work? And how do you make sure you are spending enough time on Trud?
Something to ponder as you tackle your next challenge, whether it's in the lab or the boardroom.
Join us and keep your curiosity well fed. Who knows? The next video might be exactly what you didn't know you needed.